I had a discussion with Anthony, who sent me an email earlier today talking about some of the difficulties of intersecting the planes and the results that happen with it. When we kind of mock these out, we try to do tests, and you try to debug them as much as you can in terms of like this geometry. But when you launch 50 odd ones out there, you're going to come up with mixed results and things like that. So one interesting thing I noticed, and if he found it, it means that I'm sure another handful of people have done it, is some of the results from running the intersection. So this might be something that you ran into as well. Let me just make this a little bit more accessible. All right. So when I run the intersections, and this is the step from last time, so I'm just going to intersect my three surfaces. Give them a better color there. Let's see. Nope. There we go. You might get something like this where the intersections are running a little bit tighter, and that doesn't mean really anything in terms of like right or wrong. It just happened because that's how your surfaces happen to interact. People use different strategies and different methods to go about it. It's definitely not a problem. I know we talked about last time as a scenario being, if they're intersecting too much, you could move one of them along that plane. And I think something like that is still definitely a way to go. Let me just, I got some duplicate objects here that I want to get rid of. But if that's, in this case, that's not going to be enough, because we've got this vertical member that is a really big kind of shift that happens, right? It's going to cross up and make a really complicated surface. It's not going to play well with splitting the volume. I think one method, and I think, Anthony, you could speak, I think this is how you generated these other volumes that you had in here, is to just use these three planes to subdivide the cube itself, to create a series of subdivisions. So you're still using your diagonal slices, but now you're just using them to segment up the volume and then reassemble that volume into a landscape that's a little bit more manageable. You're going to get a lot of very similar appearing volumes as the one before, but it's something that you can actually manage a lot easier, because this would require so much manipulation that it gets to the point where you're just referencing a reference of a reference, and it gets arbitrary. So I'd rather kind of keep within the logic that we've established. So you can see just by doing that, field of objects can appear probably pretty quickly, right? I mean, this is basically breaking it into constituent volumes and then rejoining them, maybe doing some orientation changes and things like that. So how do you go about that? Well, let's say I'm in that situation, or you're in that situation. I've made these intersections. They look like problematic, and when I've tried to do a loft or something like that, I'm going to get some kind of tough results occurring in it. So I'll just loft that, and I've got something like this kind of bow tie surface that's really kind of hard to incorporate. Let's pick it for a second. That's nothing that I actually want to try to move forward with. So instead, I'm going to take this and just split the cube up. Actually, I got it back with those surfaces. So this extrusion here, I'm going to split up. I'm going to hide my curves for a second, and I'm just going to run the regular split command. So I don't want to try to do a Boolean split, because if I try to do a Boolean split with these single surfaces, it's going to give me really odd, unpredictable results. So my object to split would be the cube, and my cutting objects are going to be those three surfaces. and that's going to split it up into 8 pieces there. You'll notice when you get those 8 pieces that they're going to be kind of open because you just slice through. But you still have those planes there, and you can use the Create Solid tool to close these up afterwards. So now when I'm left with this little piece here, they're all going to look something like that, right? I can use the resulting extrusions that I still have to kind of close that object up. So this, in this case, it wouldn't be the one down here, it'd be the one that comes over here. Right? You're kind of like putting it back together at that point. So if I want to take, what I'll do in this case is I'll grab a poly surface and I'll close it up with the flat surfaces. So I'm going to go to solid, and I'm going to do a create solid, which is down here at the bottom. It's going to ask for intersecting objects. So I'm just going to pick one of my poly surfaces, and then I'm going to look to see what I need to close it up. If I pick extra things that aren't needed, it's not going to really hurt me too much. It's just going to kind of ignore it. So in this case, you know, I pick all 3 extrusions, right, and that would close it up. And all you want to make sure is when it says delete input, I just want to make sure it says no, because that'll delete those flat surfaces and I want to keep them around. So I hit enter, and it says create one solid. So now I've got a solid there, and I'm just going to hide that to kind of get it out of the way for a second. And I'm also going to hide. Okay, so I'm down to that now. Those are just all edges. So I'm just going to repeat that. Create solid. And the requisite for this command is that they're intersecting, which we know they are. This is not one. This is one. All right. Oops. Let's do one more to get the point across. Extrusion. Extrusion. Oh. I'm in the hide command. So if I say show, you can see I've done 1, 2, 3, 4. That's the extra junk. I've done 3 so far. That's going to put together that whole object. I just continue and do the file 8, and that's going to constitute the whole thing. From there, what I can do is a kind of a series of operations. So let me go back to my red layer here. And it's a matter of doing unions, just using the Boolean union command to join them back together. So let's say I've got, move this up and out of the way a little bit to give you some clarity. And so let's grab another one. Simple Boolean union. I can do an assembly that way. I want to make sure I do that union just so that later on when I'm going to go start to actually construct the model, I can have a single solid to slice through. If you have these kind of extra surface breaks, these are a product of having multiple things that you've joined together. They're not really bad as far as the solid's concerned. But if you're worried about them and you want to kind of clean it up, there's kind of 2 ways to approach it. You can go into your display. If it's getting like too visual, too much noise, you can go into your display and say uncheck to show surface edges. That's going to get rid of the actual ISO curves. And you can see I've got a seam here just for the face. I can also merge my faces together. So I should be under solid edit tools, faces. Merge all faces. I pick a poly surface and it's going to merge my faces together. It's just going to turn it back into 6 faces. I mean, it's going to operate the same, but it's a little bit cleaner and a little less cluttered. So is there any kind of questions on that approach or anything like that?
This is basically a different approach than what you showed last time. If you're running into issues with your...
Yeah, it's all about those curves, and it's kind of a luck of a draw kind of thing. You know, the ones I picked, I didn't plan it that way. They just happened to kind of work well and loft together. And if you get, there seems to be this other one out. Does anyone else have one that looks more like this?
Yeah.
Yeah, so it's a mix and a match. If you have this, then this is an easier route to go. You know, you're going to get, you know, this, he didn't really exhaust all the possibilities, and he's got that many just from, it's basically like a Jenga type of thing where you're kind of fitting it and you've got a lot of options. So I'd say either one are valid, and both of them are reading off of those first 3 planes. So you're going to be fine going forward when it comes to your horizons and things like that. Is there a question?
Yeah. Is there a you still get a square on the top view that you did the last time?
Mm-hmm.
So you're gonna have to like adjust, like connect them to form a square from one view.
You don't have to,
No?
but you could if you wanted to. It's more about what kind of keep going on. It's more about like what you're interested in terms of what kind of space, and it's also more importantly about your massing volume, because there might be somewhere whatever would result in projection in plan view to be a square, like you said, just you could bury what you've got, or it's just like hanging out a lot, and it cut it, and you just don't agree with the way it's dealing with that massing thing. You know what I mean? It's very much the design of the landscape, and this is more of this found object that you're going to later manipulate and change. But right now, it's kind of this first design is the design of the landscape itself. So, and keep in mind that, you know, it might actually, I think most of these, when you look at them, have a projection where it will be closer to a square. Sometimes it is the top, but sometimes it's an elevation as well. And neither one is bad, right? Because we're really defining right now with the orbit's the grounding object. So our orientation is still up to us. It's what's going to define it, right? The light source itself is going to be intercepted by that landscape. So, and again, when we talk about the logic of the construction of the model, that might give you a clue too as to where to go. But I very much promote this approach because it's quick, and it gives you like a catalog of things to compare to. You don't have to kind of memorize what they all looked like, and you can kind of really quickly. Once you run that approach that I did, and you've got just these 8 puzzle pieces, make a bunch of copies of them and just start doing different combinations and testing it out, and bring along the massing one too, right? But, anybody else on that topic?
So there's no minimum number of pieces that we have. We just have one that can hold that massing model.
Right. Well, so when it comes down to it, you're finally going to be asked to go forward with one of them into the next step. You know, the great ways about this and the other process is you're not signed. You get to decide which ones. They're all technically valid because they all follow the process, and they're all going to have the same enough information to move forward with. So, yeah. From here, you basically go into this where we left off last time, and like with that base, you know, he's got something. That, let's say he went forward with this one, this poly surface here. He's going to do the same steps that somebody that left off where we left off with that last workshop, and that's going to be the actual model construction of it. So the best thing I can say is like when these kinds of things happen, when we're pushing this kind of much geometry around, communicate. Don't like freak out or think like, hey, I've got to force this through. Just like form the dialogue and be like, well, I did everything this way and look what I've got, and I don't know exactly what to do about it, you know. And it's like, oh, this is a cool opportunity to actually address this issue. So yeah, definitely reach out like that. So that's like the first thing I wanted to talk about. The second part is, are you guys okay? Well, on this topic.
I have one question.
Yeah, go ahead.
If you do the loft and you like part of it, but it's that volume, could you do like half and half, like loft it and then make the volume go over the loft? You know what I mean?
That would be tough. I'm not sure how you would pull that off, because then you'd be just left with a piece and then that thing. So how are you going to make that work? Because this thing is, there's a specific separation that happens. I'd have to see an example of that to kind of see how it would work, because the loft is going to give you a two-faced poly surface.
Yeah.
And then you've got another chunk here. It kind of all depends. It's not going to want to, work well with it. You're going to have like some loose end. But again, if you want to like shoot me an email and be like, this is what I got, check it out.
I might just mess with it a little bit.
Yeah, mess around with it. It could work. It's kind of like if A and B satisfy, then A and B would probably work as well. I'm more worried about the intersections and stuff, but I would give it a shot. It's worth trying, definitely. You always want to try and bend it and see how far you can go on it. There's another one. Somebody else that had their raised hand.
When you put the nesting model in the middle of that, could you do a Boolean split? You create a pocket for the model, or should you just leave it at that?
No, yeah, you still do that part.
Okay.
Yeah. This kind of gets us to that part where we had it, and then you would still do the split and get it out of there. You can do a difference too, because the split's going to give you that third thing, which is the intersection of the two, which is fine. You just have to remember to delete it. That's going to give you the intersection as well. So the Boolean split works too. But yeah, so this is going to leave us kind of with what we had last time, which was actually that's too much. This is those two things, right? That's what you're talking about.
Yeah.
These two guys. Yeah, that you do that Boolean right out of that one that we had before.
And that was the split or the difference?
Either one would work. With the difference, just make sure that you say delete input equals no.
Okay.
And if you do the split, you're just going to get the third object, which is where these two intersect each other, and you're going to need to delete it. But either one's going to work. Good question. Anybody else? So the next part is like, all right, now how do I build that? And what we're asking you to do on this one is to do a waffle structure of the landscape itself. That's going to give us something that is strong, but still lightweight enough that we can access through it. We can get it together relatively quick, and it's flexible enough that we can fit that object in there. Now, we're going to plan this out in Rhino and produce it, but there's always going to be physical limitations, especially if I've got some kind of geometry that mine kind of does a wedge, and I could probably get this one to kind of socket in there pretty well. But let's say maybe it got wider at some point, and it doesn't want to fit in there as well. That's when it's going to take some manipulation on your part to do it. So I don't expect the first kind of waffle model that you make to be the right one or the perfect one. But if you run through it one time, you can start to like anticipate that, oh, maybe I need to clean something up, or maybe I need to delete a part of my model or something like that. I might have like an extra thing at the end, and that's just what you got to do. You got to kind of clean it up and start taking care of this thing so that you can get something that's usable out. And you can always physically manipulate the model once you've got it there, but it's a lot easier to kind of do some of that stuff ahead of time, So yeah.
Can it be done in parts as opposed to one solid, like that waffle base? So let's say something fans out and you can't really see
Yeah.
it in, so like you
Absolutely.
do a bottom part and a top.
Yeah, sure.
Okay.
And that's definitely a way to go. I was anticipating that question later, but we could talk about that now too. That's going to be definitely an option for you, because I'm seeing a lot of like more regular shapes. I'm doing a simpler one in here just so you can see the process run through. But a lot of times what'll happen is you can attach two parts and you do it kind of cleanly. That works really well. You can also well, I'll kind of explain. The way we split this, there's different ways to split the waffle seam to make it work a little bit better. You don't automatically just like slice it like this and assume it's going to be great. You can be a little bit more productive. But the short answer, my long answer was all that, and my short answer is yes on that. Yeah. Because I mean, life is not always like, oh, it's just perfectly gonna waffle out like that. There's another thing.
Yeah. When you said take a little piece off of the model, that thing.
Mm-hmm.
Because in mine, I have like a little.
Right, you're gonna get
sticking out.
These kind of things up top,
Yeah,
right?
am I able just to delete that out of it, mine?
Yeah, right. We talked about that. Yep.
Because that would have been annoying as hell.
Yeah. So this, you know, we're kind of treating that extrusion and that intersection as kind of the starting point, and from there it is yours to move on with. Right now we're kind of limiting to, I can delete this, or the other option is I can maybe graft it later on. So maybe in terms of, let's say, the other case is you've got a little piece like that and you actually want to keep it. You don't want to keep it in terms of just like this detached piece, but you know you want to keep it. Then keep it for now, and then when we go, and you'll start to see it when we look at the schedule, like, oh, well, now I can bridge this or graft it or attach it somehow into, fill it up, right? To kind of repeat that this is not saying this object here, and you can start to see that once you see these wireframe models. This does not mean that this is solid and that is void, that this is in and this is out. This is just where we're starting with. This thing is going to take on the inside and the out and all that stuff once you actually take that wire model and start building on it. Yeah, so if kind of keep that in mind, right? It's like you can chop that off, or you could just kind of keep it around for later and use it differently later on. And right, it's a one-way street, so that's why I kind of say use caution. You might be looking for space later and wish you would kept it, so maybe just keep it on the side or something like that. Yeah. So I'm gonna turn this massing volume off and just deal with this as far as my base is concerned. With a waffle structure, it's actually super dumb in the terms of like the math and everything else, and the kind of assembly to it. It always looks a little impressive because there's a lot going on, but it's not hard. I think the only way you can make it hard is if you don't keep things organized in your Rhino model. So I've got, like, under waffle structure here, I've got this kind of litany of layers. It's just going on. It looks like much, but it's really not that much, and it really just lays out the steps on how I want to do it. And all I want to do is just keep things organized and just kind of run through the steps in the right order, and it kind of takes care of itself pretty quick. So it always looks more impressive, and like you'll do it and you'll be like, okay, it's just it is what it is. I've got my orbit on, so I'm going to turn it off. So let's just say you've come out, either process you've done the lofted in the surface and you've brought it over, or you've done the kind of Boolean union of your subdivisions. You've Booleaned out this kind of socket for your mass, and you're like, oh, I want to build my waffle structure. I've got my cardboard. The first thing that I want to do is I want to create contour curves of it. And we're recommending a 2-inch spacing on the waffle structure. That's going to give us something that's still pretty low amount of material versus high amount of strength. So I'm going to do contour curves. And I'm going to go into curve from objects and run contours. The one option I always point out is you want to join curves by the contour plane. So that means whenever we slice through, we're going to get a closed curve that is just sliced through that object. Current layer, that's good. Group objects by contour plane, not important. That's more for when if you were to cut through a bunch of different objects with one contour plane, then it would group it. So I hit enter. It wants to know the plane base point, which is basically showing it a direction to run in. So I'm gonna do this, and I'm gonna do a series in the X direction and a series in the Y direction. So the first thing I'm gonna do is tell it what that X direction is. And if you're not sure, you've always got the world coordinates down here on the bottom left of the Rhino viewport. So I'm gonna go and say that's my X direction. You want to make sure that you snap to at least one end, because that's going to be the first contour slice. So if you snap off the model, it's not going to care, and it'll do that in air. and the next one will just end up somewhere in your model. So you want to make sure that that looks good. So I say okay. My distance between contours, so I'm going to do 2 inches. Okay, now that's given me my X direction curves. I've got it on its own layer, and because our cube is 20 inches, I've got one on the end and one on the other end, which is a good check to make sure that everything is equally spaced. If you don't see a curve there and a curve on the other side, you want to check your overall dimension and make sure that I've got a 20-inch model and that my spacing is at 2 inches. So I'm going to do the same thing in the other direction. Just going to repeat the command, contour. I've changed my layer to Y, only one object. I don't want to pick the other contours because that'll intersect the other contours. And if they're in your way, just turn off the layer. And those are going to create extra geometry that I don't need. So my Y direction is going left to right now, so I'm just going to tell it that. It remembers from last time that I want 2-inch contours and that I want my curves joined by the plane, so I just hit enter. All right. So now I can turn off my landscape volume, and now I've got curves in all these directions, right? So far, so good?
What is the button that you're pressing to make it go in the X or the Y direction in that subcommand after?
It's just asking, and I'm just snapping to a start point and an end point. Yeah, and I don't even have a choice. It's just gonna automatically put you in that mode every time you run that command. So I've got these curves, and the next thing I want to do is get rid of the perimeter, because when you do a waffle structure, you can't really keep the perimeter parts. There's not enough material to grab on, and then just going to pop off, and it looks pretty bad. And you're not always trying to show the entire volume. You're letting the extensions of the protrusions showing a volume. So I'm going to get rid of those now, and I'm just picking the 4 curves on the outside. So I'm just holding down shift, and I've picked all 4, and I'm going to delete them. So you should now have 9 in each direction. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. So I've got 9. This is when you like I've got issues. As cool as this model actually I think looks, like, what do I do with issues like that? I don't know. That's why you're a designer. So I want to know what you're going to do. You can maybe try to keep that around and poke it through. I think on this case you could definitely still keep those holes in there. All right, so I've got curves. Now I actually want to turn these things into surfaces. So I'm going to go down to my surfaces layer. I'm going to turn off the green and make my X surfaces. And that's just simply doing by surface planar surf, which is planar curves. So select them. I'm going to pick my curves. That's it. So now these are planar surfaces. You'll notice that because I've picked a surface that is has 2 planar curves that are circumscribed, it's just going to make it a hole. Whenever you run that command and you've got a curve inside, a closed curve inside of another curve, it's automatically a hole. It's fortunately it knows to do that. But I've got another issue there. Like, that's an issue in terms of model building, where I would probably just slice that little thing off, because that's inside the model and it's going to end up breaking off anyway when I build that thing. It's kind of, that's something I'd probably manually do once I've gotten it out there. All right. Same deal for the Y. So everything I do, I've got to run through twice. Make my Y surfaces. All right. So this is kind of the state of affairs. You can already kind of see how this thing is going to work, right? It's got a pretty strong looking model. It's only going to have 18 pieces total. The next thing I need to do is I need to establish where these are going to intersect, and I need to give myself this kind of dummy geometry that I'm going to use later on to create the sockets so that this thing will waffle together. They're all going to happen at these intersections, and there's a couple of things that we need to remember about them. They don't have to all run at the same height. That would make sense if we were waffling a cube, but for here it doesn't make sense to do something like that. And in those more extreme examples, it definitely doesn't make a sense to do something like that. You want to kind of be smart about it. We also know that they want to have square ends, so even though these things might be at different heights, we needed them at square ends because our cardboard is going to cut square. So we can't have things like coming out sockets that are crooked and things like that. For that reason, for those reasons, we want to just have we're going to start off with just a long vertical curve. So this contour intersection layer here is that, and I'm just going to intersect. I'm going to pick these two surfaces. I'm just going to intersect them. Okay, that's going to give me a curve, right? That curve, I'm just going to use the gumball. I'm grabbing the blue scale, and I'm just scaling up big enough that, and I can move the gumball. I can move it up big enough so that it's just bigger than everything else in my waffle, something like that. You know, if you wanted to, you could turn on the cube and make sure it's as big as a cube and stuff like that. It's more important for the top here because the top is not flat than it is for the bottom. If it stopped at the bottom, it would be okay. We're going to use this to create like a column that's going to get subtracted out. So I've got this, and I want to have one of these for every intersection there is in my model. So I'm going to do a rectangular array. Number in the x direction. I'm going to want 9 because that's how many I've got, and 9. And z, I only need 1, so I say okay. It wants to know the spacing. My x spacing is going to be what? 2? Yep. And 2. But looks like with my, oh yeah, okay, so I picked a bad intersection to do that with. Right. So I'll say my x spacing needs to be -2. And my y, no, actually that one's good. X spacing is 2, y spacing is -2. So you can just tell it what direction to go in, right? Say okay. All right, now I've got these guys. So now it becomes, the question is, where do I want to split this thing? And the way I'm going to do that is I'm going to just create a plane that's going to split this object. It's going to just split these blue curves that I made. So another layer. I'm calling this thing the Waffle Midpoint Splitter. Really kind of over wordy, but that's what it's doing. I could go about it a couple of ways. I just want something that's big enough. If you want to play it safe, one way you could do it is turn on your original landscape volume and do like an extract surface and just set the copy to equals yes, and you'll just extract a copy of your bottom there, and then just put it on that layer and turn that off again. And now I've got this surface that I know is the right size, right? So if I was only making a box, I could just go pop up to the midpoint and that'd be good. But I've got a little bit more going on in my model. I've got this kind of overall slope happening. So I think what I'm going to do is I'm going to hold down Control and Shift, and that'll let me just grab the edge of that surface, and I'm going to move the front of it down. So like maybe what the midpoint is more in the front, right? Something like that. And I look in the back, and looks like I might be able to do the same thing and hold down Control and Shift and grab that edge and just use the gumball and move that thing up a little bit, maybe like that. It's going to be a judgment call, right? So if I had something more complicated, like Zed's talking about, you might have to do a little bit more legwork on this one, right? So if I'm in a more complicated model, maybe it has like an overall L shape, or you got like a cliff or something like that, you can still do this. Maybe what you do is you take this, you can split the face of it. So now this is a poly surface that has two faces on it, and I can grab it and start manipulating it through whatever my waffle model is, and kind of just putting it up and through and slicing it into different parts to have something a little bit more complex. Or you could just break it in half and split one this way and split one to the other. Right? Test it out. I mean, it's free. It's not costing you anything until you actually build it. So it's all going to be on a case-by-case kind of thing. I still got everybody so far? Yeah? Okay. But I'm going to go back on my easy version here where it just splits. And let me turn these off. So this is kind of, the next step is to create curves on the top and curves on the bottom. The curves from the top are going to get popped out of one direction, the green ones maybe, and the ones on the bottom are going to get popped out of the other direction, the red ones, and that's how this stuff's going to fit together. So I'm just going to split them, edit split, objects to split, those are my curves, cutting objects are my surface. You always want to make sure that this number up here makes sense, so I want 81 into 162. That's good. And I'm going to put these on different layers. So I'm going to grab these curves. I've got a layer called contour intersections split top. So I'm going to change the layer. And I've got ones that are on the bottom. I'm going to change that layer. So now they're on separate layers. I can turn that off. So if I pick them, I should have something like that and something like that, right? But it's actually kind of nice to have this thing here to kind of police the whole situation. So next thing is to make these solid. For this, I want to use the multi-pipe. Where's Khalid at? Your friend the multi-pipe, is he here? With the smiley face. All right, he's freaking out about the smiley face showing up on the multi-pipe not loading. So this is a square cross section. The reason why we want to do it now and not later, because if I slice these while they were solid, I'd have all these diagonal surfaces on the bottom. So I've got to wait till now to pipe it. If you guys have this plugin right, you know where to get it. Yeah. If not, I'll put a link on it. Yeah, the link's on there, right? On one of the earlier videos. So if you don't have it, go to the earlier video and you can download the, bring it in there. Curves for pipe, I'm going to do top. So this is going to come down to your cardboard, how thick your cardboard is. So you're going to have to measure your cardboard. That's going to be your material thickness. Let's say I've got 3/16. So I never want to trust my abilities at fractions. So I'm just going to use a calculator there and say 0.185. 75. Remember, in this plugin, you don't want to put a space in there. Just go right into the number, so it's 0.1875. Okay. Okay, so now that these have the thickness based on my material, I'm going to do the same thing on the bottom ones. I'm just going to change my layer to bottom, call it pipe to bottom, and hyper pipe. Get the curves for the pipe. Oh, almost missed that one. Enter. Unfortunately, this doesn't remember our values. Okay. Cool. All right. So now we're actually ready to get this thing sliced out. I'm going to turn this off. I'm going to turn on a new layer. Let me get rid of these guys for a second. And the next thing I want to do is with my surfaces, I'm going to give them a thickness. So I'm going to do an offset surface. I'm going to offset these surfaces. My distance, I want to make sure that I do both sides. So it says solid is yes, corner sharp, both sides equals yes. You got to be careful on that one because it wants to reset. Delete input, I'm going to say no on that. And I want to check this. This should be half of that distance that I just punched in, but I don't want to trust it. So I'm just going to go back and make sure. I got my calculator panel here. And I'm going to say 3 divided by 32. And that checks out. If it didn't, that's the distance I would type in. Alright, so now I've got a solid thickness to my what used to be flat surfaces. I'm going to do the same thing for the Y surfaces. It remembers everything except I remember both sides now, so that's good. Cool. The last step, and you can see this is why we extended those curves first, because if we just ran the intersection, the pipes would stop right there and you'd have this loose stuff hanging over and it wouldn't, the Boolean delete didn't work. So it's a little bit of an extra step, but it gets this kind of clean separation going on. This one's going to be more a judgment call on your end. I don't, you kind of just have to decide on which ones to subtract it with. Each way is going to work. You just want to make sure that you've got two different subtractions going on here. So I think what I'll do is I'll take the top ones out of my red ones. I'll do a Boolean difference. And I'm going to do the same thing, but I'm going to take the bottom ones out of the green. Looking good. You can always just double check and just say select objects on that layer, and that'll make sure you got everything. Select objects. There you go. Voila. So now this thing is ready to go. Somebody tried to start clapping there. I appreciate the effort. You thought about it. You didn't want to stand out. Hey, don't thank me. Does that make sense so far? So it's a little legwork, but look what you come out with. I mean, this is there in terms of like the logic. You're always going to have the materiality to deal with, so be extra careful when you're measuring, right, the thicknesses. Another thing you could do is if you're having issues with your solid, you can overshoot it a little bit with when you do the multi-pipe and the diameter. You can give yourself a little extra space or a little more space depending on, or a little less space maybe if it's too loose or something like that. That's going to be a matter of tuning. Just be kind of really careful. Kind of remember that you can compress corrugated cardboard a little bit as well. It'll take a little bit of compression, so maybe you give it a little less and to try to keep it tighter. So now I've got it out. This is great, but it's like, now what do I do? Like, you want to kind of lay this out. You can either lay it out and print it out, cut it. You can laser cut it, whatever you need to do. You still need it flat and organized, right? So we need to lay it out. There's a ton of different ways to lay it out. What I'm going to do it is I'm going to use the section tools plugin. And I can put a link. I'll put a link up to the sections tools plugin. but it's a nice plugin that makes sections and maintains them. It updates sections live. It does a lot of stuff. Another thing it does is it creates an array of sections and allows you to nest them out and label them and stuff like that too. So I'm going to do section tools. I'm going to create an array. What are the objects that I'm going to do? Well, right now I'm going to worry about one at a time. I'm going to create sections of my X waffles. So I'm just going to pick it. I don't want to cut through everything, right? I just want this stuff. I don't want the other ones that it'll fill it in and all the other stuff. So, okay. My direction. Well, this is not the right direction right now. It says x-axis, but that's the section direction. So I actually want to change it to y-axis. Replace, no. Name x. That is going to give a prefix to the section name. X is good for me. I want to keep it at x. My start index, I want to change to 1. My number of sections is 9. My spacing is 2. We got some other options in here, both sides now. Attributes, solids, labels, arrow scale. The arrow scale is something you want to not have at 0. As long as you don't have it at 0, you'll be able to visibly see these sections in your model on a layer that you can turn off and on. If you say arrow scale 0, they'll be invisible. For my section, I just want to pick the first one and grab a midpoint on the thickness. They guarantee it'll cut through there. Don't worry about laterally how it lines up because it'll be an infinite plane. You just want to make sure that it cuts through a midpoint on the material thickness. This is another reason why you want to actually build the material thickness in your model. All right, it's thinking right, and what we've got here are all my X sections. Those are hanging out right there. You can kind of see them. They're yellow. If I turn off, so those are hanging out. They're labeled. I'm going to do the same thing for the Y ones. Run the command again. Section tools, create array. This time my objects are going to be my Y ones, right? So I've got to change the direction. This time I'll change it to the x-axis, so it's slicing through them. And I want to change the name to Y. And my start index, I want to do it at 1. You can really do it any numbers you want. The purpose is just to not confuse yourself. So whatever's going to get that for you is what's going to work. And that looks good. So now I've got my Y sections as well. So the way that this plugin works is you've got these kind of sections in place. You can see that they're all kind of on separate layers as well. They're locked. The layers are automatically locked. There's one per layer. But it also has a memory as a running list of what sections you have in your model now. So if you need to turn these off, they'll be there later on. But right now we want to just nest them and flatten them out. So I'm going to go into create array. I'm going to say nest 2D layouts. Select sections. I can either just grab them, which those are all my sections right now. You can see that I can just physically grab them, or I can go to the list that'll allow me to select them all. It's going to give me the same ones. All right. So again, I'm going to do sections, nest 2D layouts, pick a base point. And there they are. So the Nest 2D layouts just puts everything in a line for you. If you want to individually place them, you can do 2D layout, and it'll kind of load your cursor with it, and you can just pop them where you want. And then when you run out, and it'll do it, right? So at this point, it all depends on how you want to lay it out. If you have like a if you know the size of what you're cutting out of, you can give yourself like a little frame. So I would just give myself like a, and let's say I've got a piece of something and it's like
36 by 46.
there you go, 36 by 46. So I'll do 46 first, 36, something like that. Make copies as necessary and just start to lay these things out and try to get the most out of my material. It's only, you know, there's different methods that we could automate this, but you're only dealing with really 18 pieces, so it's kind of quicker just to pop them in there yourself and make it work. So they're laid out, but I'll kind of remind you, you got these annotation dots. They're not going to help you too much when it comes to like laser cutting or something like that. So we're going to use that convert tool again to convert to text, right? That's convert dot. And I'm going to pick my dots there. And my output's going to be text. Give it yourself a height. Mine's 1/2 inch right now. I'll see how that looks. I'll say delete input. No, I don't want to delete the input. So right now what I'll do is I'll put that new stuff on a new layer called text. Select last is going to pick the text, and I'm just going to put it on that layer, change object layer. And let's see, select dot. I'm going to try that one again, select dot. Hide those for a second. So now I've got my text. Change the size as I need it. I would move them up a little bit, and I would put them somewhere that I can see them, but when the model's built, they're not sticking out. The worst thing you want to see is like a nice model and you see like X5 sticking out on the side and it looks just kind of unplanned or stuff like that. So I would take it and just put it in there or something like that, something that's going to be tucked away later on, but I can see it now, and when I put it together I can pop it out and kind of see what's going on, right? Kind of manually move those out and then export them into whatever I need them to be. Yeah. Yeah.
You're gonna be an order put in for cardboard?
For cardboard?
Yeah, I mean, 'cause that seems like all of us are gonna have to get a whole lot of cardboard.
How about we talk about that when I'm not recording? So no one has to sit through on YouTube and listen to us talk about cardboard. We'll talk about that stuff after the fact. Yeah, but there's places that that have cardboard around here more than you could ever hope to buy. That's one thing we won't run out of. Any questions on in this process, or any not make sense or anything like that? So it's more than we've done so far, but I don't think it's out of anybody's realm. I think you guys are getting better and better with the tools, and take your time, run through the process a couple times. So that's getting us over the waffle structure. And then the last part is to talk about, because you're not off the hook yet, I'm going to tell you how to set up for the drawings. There's a couple objects that we're going to make in the model that are going to set up for the drawings. And the lexicon is kind of important for the operations that we're going to do later. So I'm going to just hide this stuff that I made for a second. And let's see, I'm going to come back here for a second. So just for kind of clarity, I'm going to go back and treat this by looking at the volume and the actual massing volume. This guy. We need to do a couple things to set up for the drawings. One of the things that we need to do is we need to establish what we're going to call a nexus point. That's going to be the midpoint where the orbit is going to shoot the light rays down into our project. It's going to be a reference point, not a literal one-to-one, but it's going to be used in terms of like a diagrammatic method of showing the light paths and things like that. It's also going to be used to create a clock. So we're going to subdivide that orbit into 24 parcels, and each one is going to be like a clock when viewed from different views. And so that way we'll be able to establish what hour it's dark, what hour it's light. How it's established is the landscape and how it blocks it and how it interferes with it. So this is totally within your realm of control. If you want to have a dark and a light, that's kind of like we have here, I would say do a landscape like this. If you want to have a couple sunrises in a cycle, you're going to get a little bit more into what you do with it. It's totally up to you. But either way, we're going to need to kind of get that going in our model. So the first thing I'm going to do is I'm going to create the Nexus. This thing right now is one volume. And for up until this point, that was okay. But I've got it. I've got little bits and parts in it. And what if I try to find the kind of volumetric center of this? It's not going to be very accurate right now because it's going to end up creating a bounding box around the whole thing and giving me the center of the bounding box, and that's going to seem kind of random. When I did it for this one, for instance, it kind of goes like down on this edge somewhere. It's kind of not even close to the real middle because it's taking into account this whole object. But if you run this command on one of them, it works pretty well. And for me, I'm kind of treating this as my main one in the center here, right? So what I'm going to do is I'm going to extract this one. So I'm going to do extract surface. I'm not going to do a copy. I'm just going to extract them. And extract these. Extracted it from the poly surface, and I'm just going to rejoin them. Alright, so now I've got a poly surface here. Look at it, and it says it's open. And the reason it says it's open is because of the kind of shared edge that it has here. It's not kind of technically closed. So if I go into my Analyze and I go into my Edge Tools, Show Edges, what it's showing me right here, this what's called a naked edge means that it looks like it's joined together and watertight, but it's not. It just happens to be in the same place. What likely happened is that this kind of solid here on the left-hand side claimed it, and it's joined up over there. And this one's kind of like what's left over. It mathematically is not giving me that left edge. So what I'm going to do is I'm just going to run that extract again on this one. I'm going to delete it, right? And I'm going to take this one and cap it. Now when I look at it, I don't have any orange on it anymore. And I look at it, object's properties, and it's closed now where it used to say it was open. That matters for me, well, for a lot of reasons, but in terms of this project, when I want to get the volumetric center of my main object, I want it to be closed up. It could work, maybe, if I'm lucky, but I don't want to risk it. That's a kind of quick way to address it. You may or may not have that issue. You might have to just test out the centroid first. So I'm going to go into Analyze, and on my layer here, I've got a layer called Nexus Point. I'm going to go to Analyze, Mass Properties, Volumetric Centroid. It's going to give me the number right there. It's also going to produce a point object in the center there. You guys know what a centroid is, or have heard of a centroid, I assume, right? From like statics class or anything? Or you guys had to deal with that stuff yet? Write it down in your sketchbook, and then like you'll have, when someone starts talking about it, you'll have like this picture of your model in your head, and you'll know exactly what they're talking about. This is kind of like a balance point for any kind of mass object. This kind of goes back to the roots of Rhino, where it was dealt with as a plugin for marine architecture, and they need to know centroids of poles and things like that to balance objects out. For us, it's going to give us a nice reference point to do a couple things with. So I'm going to scale up my orbit, because right now, if I go back to my orbit, let's look at my original landscape line. I think this is actually an orbit that I've already scaled. I've scaled it down a little bit, so I'm going to descale it and kind of show you what it used to look like. That was the original size. And yours is going to be something like that, more or less. What we want to do is we want to scale it up. We want to give it some breathing room. My recommendation is to try to scale it. So I'm just going to use the scale option. Transform. Scale 3D. My origin point is going to be that nexus point. And my scale factor is going to be 4. Mine is a little bit off because I rescaled it with the gumball, which was not the right thing to do. So I threw off the axis of it. This is 2 uncorresponding points, so I'm going to move it back over to the way it used to be, like that, before I double dipped. So don't use a gumball, just use the scale and try out 4. This gives me a nice kind of amount of clearance. This is pretty much the scale we're going to be using when it comes to 3 of our drawings that we'll talk about later. We want something with enough kind of breathing room to give us a sense of context for it. From that point, I'm going to copy this object to, and I'm going to call it my scaled orbit. I'm going to divide this orbit up into 24 parts. I'm going to call this layer division points, and I'm going to go and do a divide curve. So I'm going to type in divide. It's going to ask me for my curve. I'm going to pick it. The drag seam point to adjust. This is actually in every kind of closed curve, even though it's closed, you've got a start and an end. It's just a thing that's glued together. So this will be the start point. This is going to determine where your hours line up. That may seem a little bit arbitrary now, but if you run into problems when it comes to the spacing of the points, or maybe even just the read in terms of your drawing, this is where you would want to come back to and kind of adjust this curve seam point. So, like as a for instance, if you had a really kind of control of it and you said, I want this to be on a specific hour. We're going to number our hours later, but this guarantees that that's going to be a point, and then it'll equally divide the curve as much as needed based on the numbers that we put in. So I'll leave it there. My number of segments is 24. I'm not splitting the curve. I'm marking the ends equals yes. I'll group the output. So according to the length of the curve, these are the points, right? This is going to be like what those numbers are and what those hours are, or is going to be a designation on your drawing. But we're going to treat these as kind of ways to clock the whole orbit. Okay, so we're almost there. Hang with me. So the last thing I'm going to do is I'm going to create what we're going to call our spokes. Right? They're going to go back into the nexus point. If I do the line command, and I want to put on the end snap. Actually, I want to put on the point snap, because these point objects aren't endpoints, they're specific point objects. And I'll go into and get rid of my landscape and my volume. And I'm simply going to connect those points together. Right? I'm not going to make you sit through that 24 times, so I'm just going to do it in Grasshopper real quick. Just that's the cooking show thing, right? They come out and the pie's done. I just didn't want to make you sit through that. Just do the line command a bunch of times. If you want to learn Grasshopper, slow down the video. But this is, Thanksgiving's on the way. I'm not going to make 24 lines. So Okay, we got our time spokes. Hold on to those. Those are on their own layer. The last thing is what, and this is a technical term. This is called a dog collar. But we want a surface that that does this thing too. We're going to use it later on in our drawings, and this is really simple. This is simply we're going to extrude to a point. We're going to extrude, and I can take some of these division points off. We're going to extrude our curve to this nexus point. So I'm just going to go to surface. There's an option under extrude curve for 2 point. So select curves to extrude 2 point, and then your point snap will take you to that, and you're going to get that surface there, and we're going to hold on to that and use that later on for stuff. So I think yeah, that's the last one. Any questions on that kind of point with the nexus and the spokes and stuff like that? Pretty geometrically simple after that other stuff we did.
You just don't pick any mass in them, any face in the model. Oh, that's the model thing back on. How you pick the largest one, I guess?
I did, yeah.
It doesn't matter. Does it matter which one we pick, or should it be more sensible?
I would pick the largest. And if they're kind of close, then maybe one that's closest to the center of your model.
Okay.
So can we fix our nexus point if it still stays kind of wrong?
Yeah, I wouldn't go crazy with it, but yeah, you can nudge it around a little bit. You know, it wants to be. I don't want to make too much of a point about the nexus point. I'm not trying to turn it into this kind of overly significant object. It is a reference for us. So the kind of more objective we are about it, the better off we are. We don't have to answer questions as to why not this or that, or it's like, no, this is just a reference. This is like complaining about grid paper alignment. It's like, no, that's just the grid paper. Look at what the drawing is. But that's a good question. Anybody else? Thanks, guys. We got the handout coming out, so I'm going to